Okay, so in question 3, we want to write down the equation of the following parabolas. And the first thing we do is write down our general forms. So your first form we could have would be y minus k equals a x minus h squared. Okay, and that actually is the form of question B. And if the graph opens up, that means that A is positive. If the graph opens downwards, the A value is negative. And for question A, we have a slightly different form because the graph is turned on the side. So here we would have the form x minus h equals a y minus k squared. And in this case, when A is positive, it opens to the right side. And when A is negative, it opens to the left side like that. So in this question, we look at our graph and then we look for the vertex. So we can see the vertex is here. So let's label that as 0, 0, because that's the origin. And we need to choose another point on the graph to be able to get the equation. So let's mark a point here. Let's use this one here. So that point there is negative 1, 1. So we mark a point and we mark the vertex. And this is enough information to find our equation. So what we do, we will substitute the h and k value from the vertex into the equation. So we'll have x minus h, which is 0, equals a y minus k, which is 0, all squared. So as you can see, the 0 would disappear. So x equals a y squared. So we're not quite finished yet. We need to find a. And a generally tells us the shape of the graph. So if it's narrower, like this, or if it's wider, then the a value will change. So that's why it's important to find a point on the actual graph. And we do have one point. We've got negative 1, 1. So we'll take this as the x and y value, and then we substitute into our equation here. So we're going to get x, which is negative 1, equals a y, which is 1 squared. So a will be negative 1. So we can write our final answer then as x equals negative y squared. So that would be the final answer there. Right, so question B, we want to get the equation for this information here. We've got the vertex, we've got the focus. So that looks like we're going to need the directrix. So I recommend to start graphing first. And we've got the vertex, which is negative 2, 5. So negative 2, 5 is here. Let's come down a bit. Whoops, let's do that again. Let me put it further down. So negative 2, 5. 1, 2, 3, 4, 5. So this is your vertex here. Your focus is 2, 5. So it's on the other side, but directly across. So 2, 5 is here. So this is your vertex. And this is your focus. So vertex to negative 2, 5. Your focus is going to be 2, 5. So that's telling me your graph is going around your focus in this direction here. Your directrix is off on the other side here. So if you wanted to add that in, we don't actually need that to do the question, to find the equation. But this length here is going to be 4. So if you want your directrix, you got to go 4 on the other side, 4 units across to this side here. So your directrix is going to be somewhere here. So that's going to be -2 minus 4, -6. So this will be x equals -6. So that would be a directrix. But as I mentioned, you don't actually need that line to get your equation. What was important though is that this length here is 4 from your vertex to your focus. So if you look at your graph, your general form is going to be x minus h equals a, y minus k squared. And we're opening to the right side. So this a value is going to be positive. We'll see that later. So we know h and k from the vertex, which is -2, 5. So we can put them in. X minus -2 equals a, which we don't know yet, y minus k, which is 5, all squared. So you're going to have x plus 2 is a, y minus k, y minus 5 rather. We've done that already. Y minus 5 all squared. Now to get a, we need to know the relationship. A is 1 on 4c. Now c is this distance here in red. So c is 4. That's that length. And we use the absolute value here. So a will be 1 on 4 times 4, which is 1 on 16. And we use the positive value because the graph opens to the positive direction here. So a will be 1/16. So you'll have x plus 2 equals 1/16 y minus 5 all squared. So that's your final equation. Okay, question 5. We want to find the vertex, focus, directrix, and axis of symmetry for these parabolas. And a sketch may help you do it and help you get the answer. The first thing, I look at the question and I consider what is one of the general forms that will match this question. And I can see I've got y equals something x squared. So I know my general form is going to be y minus k equals a, x minus h squared. And I know that a will be equal to 1 on 4c, which we'll need a bit later. So I rewrite this question as y minus 0 equals 1/8 x minus 0 squared. I do that to remind me that the vertex now is 0, 0. So that's our first component that we need, the vertex. And I know that a is 1 on 4c. So that's the next thing to look at. So a is 1 on 4c. And I note here that my a value is 1/8. So 1/8 is 1 on 4c. So in this case, c will be 2. And we'll use that to sketch the graph, and then we can get the focus and directrix from that information. So let's just draw a bit of a graph. So we've got a graph of vertex is 0, 0. So that's here. This is your vertex 0, 0. And I know my graph is a y graph. So the y graph will go upwards, and a here is a positive number. So our graph will be opening upwards in this direction based on that general form. And I know my general shape now, and I know that c is 2. So if I count up 2 units, I'll get my focus in here. So my focus is going to be 0, 2, because this length C equals 2 is this here. Okay, so that's equal to 2 units long. And if I want my directrix, I will go down 2 units, down to there. And my directrix will be here. So my directrix equation will be y equals -2. So then my 3 components. I got my vertex 0, 0, my focus, which is 0, 2, and my directrix, which is the line y equals -2. And your line of symmetry, I'll complete that in blue. Your line of symmetry is this blue line here. So that's your line of symmetry. Which is the line x equals 0 that goes down through the origin. So that's your line of symmetry. So there's 4 components for your graph. Right, so in question D, this is your equation of a parabola. The problem is it's not in a general form. We need to change the way this looks. So I'm going to rearrange some things. So let's group the x squared together with the x. So x squared plus 4x. And I'm going to push my number 8y and -4 to the other side. So that would be -8y plus 4. Okay, so we need to complete the square with the x squared and the x component here. So let's complete the square. So this number's 4. So we halve it and square it, we'll get 4. So this number we're going to add to both sides. So I'll have x squared plus 4x plus 4 equals -8y plus 4 plus 4. So I'll highlight that to show I've added this 4 on both sides. So now we have a completed square. So this can be written as x plus 2 all squared. And this side will be -8y plus 8. So I'm just going to swap these around, or I might do that after. So let's leave it like this. X plus 2 all squared. I'm going to factorize out -8 now from this part here. So factorize -8, you'll be left with y minus 1. Okay, and then now I divide by -8 both sides. So then I'm going to have y minus 1 is equal to -1/8 x plus 2 squared. So now I've made it look like the parabola with the vertex and the a value evident. Let's scroll up a bit. So this is our general form. So looking at this, I can see that the vertex is going to be y minus k. So k would be 1 and h will be -2 from here and here. So vertex -2 and 1. So this is going to be your vertex, -2, 1. Let's highlight that. Now, to get more components, we're going to need to use this a value. And we know that a is equal to 1 on 4c. So we've got -1/8 is 1 on 4c. C in this case will be -2, but we want the absolute value of c because we want the length. So c is going to be 2. So that's another component we need. So I think with that information, we can draw a quick graph to see what's going on. So our vertex is -2, 1 here. So this is your vertex. And the graph is y minus 1 is -8, x plus 2 squared. So with the general form, it's looking like this here. So it's a y graph, and the a value is negative. So the graph is going to be upside down like this. So your graph is going to turn down this way based on when I look at this form of this equation. The graph must be going downwards. And C is 2. So let's mark in the vertex, which was -2, 1. Now C is 2. So let's go down 2 units. So that's going to put us down here somewhere, because that's 1. So this point here is going to be your focal point here. And that green line is 2 units long. So from 1, we must go down to -1. So this is going to be -2, -1. So that's going to be your focal point, because we measure down 2 units from the vertex to the focus. That's this length here. And if you want your directrix, we measure up 2 units to your directrix. So your directrix must be here. So that line would be measuring up 2 units from 1 would give us 3. So this would be y equals 3. Y equals 3. So that's your directrix. Measure up. And your line of symmetry is that green line here. So this is your line of symmetry. And that would be x equals -2, which comes from these 2 values of your vertex and your focus. Okay, so that would be your line of symmetry. So those are all your components, and that's your graph there.